So today we are going to be learning about U-substitution. Now, previously we've learned how to take integrals using the power rule or just sort of reverse thinking. Like we know the integral of cosine is sine because the derivative of sine is cosine. Now sometimes you get problems just too complex for something like that. For example, say you have the integral of 2x times x squared plus 1 squared dx. Now, granted, you could just multiply this through and then use power rule. But say if this was to the 100th, it would take, days to be able to do that. But for our purposes, we will stick to squared, just because it's a nice round number. Now, the process of U-substitution is essentially to sub in a new variable for a larger part of the equation so we can simplify. In this case, the variable is u. Now, the innermost function is x squared plus 1, so that's what we're going to substitute in for u. Like when you're using chain rule, the derivative of the internal function is multiplied on the outside. So that's what the entire function stems from. So you'll see why in a second. We're going to have u equal to x squared plus 1. Because again, that's our innermost function. Now, we want to sub in this entire thing with u, x for u. So we know that x squared plus 1 is equal to u, but we have a dx and a 2x out here. Now we have to sub that in for u. So to do that, we're going to take the derivative of both sides of this equality here with respect to x. So du dx is equal to 2x. Now hold on, I just want to make sure I've got all of this in the shot. Okay, good. So, multiply both sides by dx, and we know that du is equal to 2x dx. Now, where do we have that? Well, right here, 2x times dx. And we know that x squared plus 1 is equal to u. So this whole integral, subbing it in, is equal to u squared, because this is equal to u, so u squared times du, because du is equal to 2x dx. Now this is easy. We just use power rule. This integral is equal to, add 1 to the exponent, divide by that, 1/3 u cubed. Now we know that u is equal to x squared plus 1, so this whole integral is just equal to 1/3 x squared plus 1 cubed. And there you have it. Now, unfortunately, there are cases in which the numbers don't work out so perfectly. For example, say you just took off the 2. Now the derivative of x squared is 2x. Now when you're using chain rule, you take the derivative of the inside and multiply it onto the outside. So you know that in this case, we need this to be 2x for the integral to work out perfectly. So we're going to want to multiply by 2. However, now that's not the same integral. To multiply the inside by 2, you're going to have to divide the outside by 2. So multiply the whole thing by 1/2. Now, we just continue on as we did. U is equal to x squared plus 1. Du is equal to 2x dx. Now, we just substitute everything in. 1/2 integral of u squared du is equal to 1/2 times 1/3 u cubed. So, this is all equal to 1/6 u cubed. Now 1/6 u cubed is just 1/6 x squared plus 1 cubed. And there you have it. Now, unfortunately, again, there are also instances in which even this won't work. For example, say that you have a problem like x times x minus 2 to the negative 2 dx. Derivative of the inside part here is 1. And so we're off by a full power of x. Now you can't, it's not like a constant, you can't just multiply by the outside by 1 over x. I mean, it doesn't make a whole lot of sense because it's a variable. So we're going to have to use a sort of switched up version of U-substitution. Now our internal function is x minus 2, so we know that u is going to equal x minus 2. So we know that du is going to equal dx, right? Because du over dx equals 1, multiply both sides by dx. You're going to have du equal to dx. So we can sub in, is we know that x minus 2 is u. We know that dx is just du, but then we have this x hanging out here. So all we got to do is use this equality to find x. Just add 2 to both sides, and u plus 2 equals x. So now we can sub everything in. Integral of x plus 2, because x plus, integral of u plus 2, because we know that u plus 2 is equal to x, times u to the minus 2 du. Now, we can just multiply this thing out. This whole integral is equal to u to the minus 2 times u is u to the minus 1, and u to the minus 2 is 2u to the minus 2. So this whole integral is equal to u to the minus 1 minus 2u to the minus 2. Oh, I apologize. Plus 2u to the minus 2 du. Now, we can just take the integral. So u to the minus 1 is a little tricky. You're going to have to do a little bit of backwards thinking. We know that the derivative of ln of x is going to be equal to 1 over x, and u to the minus 1 is 1 over u. So reverse think that. You know that the integral of u to the minus 1 is going to have to be ln of u. And for this, we can just use power rule, add 1 to the exponent, divide by that, so minus 2u to the minus 1. Now substitute back in for u. Ln of u is ln of x minus 2 minus 2 times u, which is x minus 2 to the minus 1. And there is your final integral, and that is U-substitution.